Okay, so today we're continuing 11.8. So yesterday we learned how to expand a binomial using Pascal's triangle. And that was where we found our coefficients. So looking at this equation, those were the p's. And those were the numbers that came from Pascal's triangle. Whichever row we were raising, or whichever row was the same as our power that we were looking for.
Where are you at? It's in the packet.
So today, we're going to go over how to find the coefficients using combinations. Now remember that combinations were this n factorial times n minus r factorial times r factorial. That was from 11.1. So we're going to use this equation now for expanding our binomials. And these parentheses with the n and the 0 are just another notation for combinations. So this would be C with an n and a 0 is what that parentheses means. It's just another way of writing combination, of writing this format. So now your n is still your n, and the bottom number is your r. So everything is exactly the same as we did it yesterday, except now we're using the combinations. So our first term, the exponent is still starting at whatever we're raising our binomial to, and then it's decreasing by 1 each term. And our second term in our binomial is still starting at 0 and increasing by 1 each term. So we're going to look at example number 1, and we're going to use this new combination style. So if we're looking at our overall equation that we have up top here, we have n over 0 in our parentheses. So we're going to have, for our first coefficient, we're raising this to the 7th power. So we're going to have 7 over 0 in the parentheses. That's going to be multiplied by our first term, which is an x. And x is going to be taken to the 7th power for this first term. And then that is also multiplied by our second term, which is a y. And our y will be to the 0 power for our first term. Now remember, when you're writing out these terms, that your exponents should add up to equal the power that you're taking your binomial to. So our next term, write out the combination, 7 over 1. Our x term, our exponent goes down by 1, so it's now a 6. And our y term is now a 1, because it increases by 1. So our third term is going to be 7 over 2. X to the 5th, y squared. Our next term, 7 over 3, x to the 4th, y cubed. Our next term. 7/4 x cubed y to the 4th. Seven over 5 x squared y to the 5th. Seven over 6 is our next combination. X to the 1. Y to the 6th. And then our last term. 7/7 in our combination. X to the 0. And I'm out of room, so I'm going to write it underneath. We have plus 7/7 x to the 0 y to the 7th. So now we have to find those combinations. So if we remember, on our calculator, we can go to menu, go down to probability, and we're doing combinations. So you'll go down to the combinations, hit enter, and you're going to enter your two numbers as an ordered pair. So for our first one, we've got 7, 0. And I'll zoom in on the calculator so you can see. So you should have the combinations, and it's 7, 0. You hit enter, and you get 1. So your combination for your first coefficient is 1. So that's this first term here. This combination gives you 1. So you have 1 times x to the 7th times y to the 0. What is y to the 0? 1. Anything to the 0 power is 1. So you have 1 times x to the 7th. So you just have x to the 7th. Now your next term. You're going to find this combination. And again, you're going to put that into your calculator. So you go menu, probability, down to combination. And it's 7, 1 this time. Hit enter, and you get 7. So this combination gives you 7. So you have 7 times x to the 6th times y to the 1st. Y to the 1st is just y. So you end up with 7 x to the 6th y. So for your next coefficient, you're doing this combination. This combination gives you 21. And then it's 21 times x to the 5th y squared. And then your next term, you're going to find this coefficient using combinations. That gives you 35. And it's x to the 4th y cubed for this term. And then our next term, 7/4 in your combination, you should get 35 again. And this is x cubed y to the 4th for that term. Plus your next coefficient is this combination, which gives you 21. So it's 21 times x squared y to the 5th. Then you have this term, which will give, this combination gives you 7. You have x to the 1st, which is just x, y to the 6th. And then our final term, this combination gives you 1 times x to the 0. What's x to the 0? 1. So you have 1 times 1 times y to the 7th, which is just y to the 7th. So your simplified expanded polynomial is right there. And again, remember, you should have n plus 1 terms. So we should have 8 terms. We've got 1, 2, 3, 4, 5, 6, 7, 8. So we're good there. So that is the simplified expanded version, using combinations. So now problem 2. Problem 2 is exactly like the first one, except now instead of having a variable as our second term, we have a number. So now, we're going to do the same thing. We're going to use the combinations method. So we're taking this to the 6th power. So you're going to have 6 over 0 for your first combination, multiplied by your first term, to the 6th power. And then you're multiplying by your second term, which is the 6th. And that's to the 0 power for your first term. So remember, you're always starting for your first term in the binomial. You're starting at the power that you're going to, and you're decreasing. For your second term in the binomial, you're starting at 0, and you're going to the power, so you're increasing each time. So your next term, to find the coefficient, we're going to use the combination 6 over 1. Y to the 5th, because we're decreasing by 1. And 6, so 1, because we're increasing our second term. And this is exactly what we did yesterday, except now instead of using Pascal's triangle, we're using combinations to find our coefficients. So our next term, 6 over 2, y to the 4th, 6 squared. Our next term, 6 over 3, y to the 3rd, 6 to the 3rd. 6/4 y squared 6⁴. Our next combination is 6/5 y to the first 6⁵. And our last term (6 to the 6th). And again, you kind of can't see it, so I'm going to move it. So now we're going to find the combinations to get our coefficients. So when we find the combination for this first one, again, you're going to use your calculator. You're going to go menu, probability, combinations. Enter these numbers in as an ordered pair, so it's going to be 6, 0. You get 1. So you're going to have 1 times y to the 6th times 6 to the 0 power. What is 6 to the 0 power? 1. So you have 1 times y to the 6th. So you just have y to the 6th. Plus your next combination. You would find this combination. This combination gives you 6 times y to the 5th times 6 to the 1st power. 6 to the 1st power is just 6. So you have 6 times 6 is 36 times y to the 5th. And you'll find your next combination, and we're multiplying by 6 squared, which is 36. So you have 36 times your combination that you were given, or that you find. That combination is 6, 2. You get 15. So we have 15 times 36.
No, which one?
So you should get 540. And that's times y to the 4th. For your next term, when you multiply out your combination times 6 cubed, you should get 4,320 times y cubed. Your next term is the combination multiplied by 6 to the 4th, which gives you 19,440 y squared. Your next term is the combination times 6 to the 5th, which gives you 46,656 times your y to the 1st, which is just y. And our last term is the combination times y to the 0, which is just 1, times 6 to the 6th power. This combination gives you 1, so you have 1 times 1 times 6 to the 6th. And 6 to the 6th is 46,656. So this is your expanded binomial. And we're going to do problem 3. Now problem 3 is a subtraction or a difference. So you have y minus 4 raised to the 5th power. So the subtraction sign makes a difference when you're expanding your binomial. And we'll see the difference it makes in just a second when we expand it. So, do you guys like Pascal's triangle better or the combinations better?
Combinations is quicker.
The combinations is quicker? Which one's easier? The triangle's easier. So on your test, you're going to be able to use either method that you want. So I'll use the combinations again just because I feel like we should do another one with the combinations. So writing this out again, we're taking something to the 5th power. So we have 5 over 0 multiplied by our first term in the binomial to the 5th power. And now, instead of having a positive number here, we have a negative number. So we have to take negative 4 to the 0 power. And you have to use the parentheses. If you don't use the parentheses, you're not taking negative 4 to that power. So then we're adding our next term, which is 5 over 1. Y is now to the 4th. You have negative 4 to the 1st power. So now we have 5 over 2, x cubed, or y cubed, negative 4 squared. And our next term is 5 over 3, y to the 4th, negative 4 cubed. Our next term is 5 over 4, y cubed. Oops. Our y here, nobody caught me. Our y here should be squared because we decreased by 1. So please make sure you're checking these. They're not difficult, but there's a lot to keep track of. So we have a y squared in our previous term, so this is now y to the 1st, negative 4 to the 4th. And then our final term is 5 over 5, y to the 0, negative 4 to the 5th. So now, our first term, the combination gives us a 1. We have negative 4 to the 0. What is negative 4 to the 0? It's 1, because anything to the 0 power is 1. So we have 1 times 1 times y to the 5th. We have y to the 5th. Now our next term. This combination gives us 5. And then we're multiplying by negative 4 to the first power. What is negative 4 to the first power? Negative 4 to the first power is negative 4. So you're going to have negative 4 times the 5 that you got from this combination. So negative 4 times 5 is negative 20. So we have a subtraction sign now. Instead of all of our terms being added, now we have a subtraction sign. And then it's multiplied by y to the 4th. Our next term. This combination gives you 10. And then we have negative 4 squared. What is negative 4 squared?
Negative 64.
Yes.
Negative 4 squared?
Positive 16.
Negative 16, sorry.
Negative 4 squared is positive 16. Remember, you have to use the parentheses. You are taking negative 4 and squaring it. So it's positive 16. So you have positive 16 times 10 gives you a positive 160. And that's y cubed for that term. So your next term. This gives you a 10 for the combination. And you have negative 4 cubed. Negative 4 cubed is going to give you a negative number. It's negative 64. So you have negative 64 times 10 is negative 640 times y squared. So do we see a pattern occurring when we have a subtraction sign? Our signs alternate. So our next term should be an addition. We've got negative 4 to the 4th, which gives us negative 4 to the 4th, and then this gives you a 5. So it's 5 times negative 4 to the 4th, which should give you 1,280. And that's multiplied by y to the 1st, which is just y.